Hello everybody and welcome back to another video. So in today's video we're going to be going over all the basics of math so you can kind of have a better overview of what math is, as well as some of the other concepts that you might study in the future. And so we start math really with the most basic that you can get: arithmetic. And so what exactly is arithmetic? Well, arithmetic is really just the abstraction of real-world numeric values. And so we look at how many pens we have and how many apples we have, and we abstract out that number value, and then we can reapply it to anything that we would like. And so arithmetic is really important for real-world examples, and this includes things like addition, subtraction, multiplication, division, exponents, and logarithms, and square roots, and other concepts like that. And so arithmetic then gives us the ability to learn algebra. And algebra is really kind of just the abstraction, again, of arithmetic. Now we're doing arithmetic, but we don't know what one of the values are. We have something like x plus 2 equals 5. And so we're abstracting this, and we're solving for some random value, a variable. Algebra is really important because it is kind of the first thing that lets us model rates of change and graphs and different things like that. And then we will go over something like geometry after Algebra 1. And geometry is just the study of shapes. We're just abstracting out shapes as well as lines, which are perpendicular to each other. I think they do like a little dash here. As well as angles and other concepts like that. And geometry, again, as you can probably imagine, is really important for real-world applications. Anytime you want to build something, you're going to have to know at least some sort of geometry. Whether that is a speaker box, a house, a fence, anything like that, you probably need to know at least a little bit of geometry. Now, after Algebra 1 and then geometry, we can kind of start learning a little more advanced math. And Algebra 2 isn't super complicated, but it is definitely more advanced than everything else you've learned up until this point. And you'll probably see more polynomials, as well as learning how to graph more complicated things like parabolas, and learning logarithms. And other concepts like this is going to be the primary focus here. And afterwards, this is kind of the end of your free trial, so to speak. After this, a lot of people say that this is where you start getting into more complicated and more advanced math. And many people don't really ever take a class after Algebra 2. But the next thing here is going to be trigonometry. And trigonometry is the study of ratios. And so if we have some theta here, then we can do sorry, this should be hypotenuse, not adjacent. And so we're studying different ratios and how they connect, and using these again in many different applications. A lot of people think of trigonometry as the study of triangles or ratios of triangles. Really though, trigonometry is a lot more than just that. And when you study trig, you will start learning how to do different concepts in physics, such as frequencies and anything that really oscillates up and down like that. I would say a big part of trigonometry is also studying circles though, because most of your class you'll be dealing with a unit circle. And so you'll be learning, obviously, all of your quadrants if you haven't learned this up until this point. You'll be learning maybe a little bit of Euler's formula, probably not, but maybe you'll see it a little bit there, and different concepts like that. And so trigonometry is what many people consider to be your first hard math class. And after trigonometry, you start diving into what people consider to be decently hard. Calc 1, Calc 2, Calc 3, linear algebra, and ordinary differential equations. Let's actually move this down just a little bit and write it all the way out. And so here you start really getting into math classes that most people probably won't ever take. And so Calc 1 and Calc 2 and even Calc 3 to a degree, you're studying rates of change as well as derivatives, which is instantaneous slope, so to speak, as well as limits to understand how you would even do instantaneous slopes. Calc 2, you're kind of studying areas under curves or the integrals, as well as other concepts like that, such as how you would get the volume of a shape that isn't easily broken down into simple shapes that we have formulas for. You can also prove different formulas using Calc 1 and 2, different geometry formulas, that is. And then Calc 3 is we're taking Calc 1 and 2, and now we're reapplying it into 3D space. That's really the big things you will study in Calc 1, Calc 2, and Calc 3. Linear algebra is all about vector spaces and taking different bases and getting to different points. And then ordinary differential equations is taking differential equations, the differential that you would learn about in your calculus sequence, and learning how different relationships kind of play to each other. And you would see something like dy over dx minus y is equal to 0, or something like that. And so we're looking at these differentials and the derivatives, and you're learning how to kind of do these algebraic problems with them. And that's kind of how I've always described differential equations, and it's not a great explanation at all. But it is something to start getting your mind around what you would be doing in this class. However, after you've taken all of these classes, especially if your linear algebra class was more real world based instead of proof based, so real world examples, then you would start getting into a completely different branch of math. Up until this point, we've been extracting and abstracting and kind of modeling the real world in a sense with all of our math. And now we go down a completely different route. So after you get past all of this math, then you start learning proper math. How to prove different ideas in math. And you would start with a proof-based class, maybe even a discrete math class, and then you would move on to an abstract algebra or a real analysis class. And so a lot of people who enjoy math and learn a lot of math consider this kind of being the difference between your training wheels and getting into real math. Of course, it's all real math, and I don't want to diminish any branch of math over any other branch. They're all super important, and this branch is definitely more applicable to the real world, but our proper, more rigorous math over here lets us, don't think there's a U right there. I think I misspelled that. But our proper and rigorous math allows us to show that everything we're doing over here is right, as well as much more complicated ideas such as topology and complex analysis and different ideas like that as well. And so once you get to a certain point, this becomes really important as well. I think our school systems kind of do it a little wrong in the sense that we don't learn this until much later than I think we should. Because this is where a lot of your problem solving skills will come from, is learning how to make something rigorous. And just because it's rigorous doesn't mean that it's not creative. There's a lot of creativeness when it comes to this different branch of math. And a lot of people think that that's not really the case, but there's 1,000 different ways of doing your homework problems, and really there's many different ways of seeing the path forward and proving these different concepts. If you've never learned any math at all, or any rigorous math at all, then doing an intro proof book by yourself or even taking a class would be really beneficial, because I think you'd kind of understand what I'm talking about when I say that this proof-based math, and let's write that up at the top, proof-based. This proof-based math really allows you to look at math from a different angle. You're not just plugging and chugging like you are over here anymore. Instead, you're really understanding the ideas that you're learning and learning why we use them, as well as what makes them proper and right. And so that's pretty much all I had for you guys today. And I think I will be starting an algebra tutorial, an algebra walkthrough here soon. Let me know if that's something you guys would enjoy, or what other ideas you would like me to cover. Thank you so much for watching. I hope you guys have a wonderful day, and goodbye.